The next problem is a stretched wire of length 0.6 meter is observed to vibrate with a frequency of 30 Hz. 0.6 meter is observed to vibrate with a frequency of 30 Hz in the fundamental mode. If the string has a linear mass density of 0.05 kilogram per meter, then find, he asked for two questions, that is the velocity of propagation of transverse wave in the string. The first one, first of all, what is the given data? Given that first length L is equal to 0.6 meter, and after that he has given the frequency of fundamental mode, means nu1 is equal to 30 Hz. Nu1 is equal to 30 Hz. We know that what is the fundamental mode. For the velocity of propagation A is equal to the fundamental mode nu1 is equal to V by 2L. He asked for the velocity, means what is the velocity of propagation of a wave. Then what is V? That is equal to, he given that nu1 is there and L is there, so that we are substituting V is equal to nu1 into 2L. Nu1 into 2L. Then nu1 is equal to 30 into 0.2 into 0.6. 0.6. From that we can get that 6 by 10. 6 by 10 means here is that 30 into 260 into 6 by 10. 10 6 are 6 6 are 36. 6 6 are 36. Here the 36 is the velocity of propagation of a wave. See, 36 meter per second. Then next one is, he asked for tension in the string. Tension in the string means the tension T is equal, already we have the formula, V is equal to root T by mu r linear mass density m. So if in case of he asked for the tension, then we can get that the square root taken this side, then it will become T by m is equal to V square. Then he asked for the tension, so that's why T is equal to m into V square. When the m is taken to this side, then T is equal to, what is meant by the m value will be the, here is given that the linear mass density 0.05, that we can write that 5 into 10 to the power of minus 2. 5 into 10 to the power of minus 2. 5 into 10 to the power of minus 2 into 36 into 36, because we got the value for V is 36. So here is that 5 into 10 to the power of minus 2 into 36 into 36, we can get the value. This will be, so here is that 5 into 10 to the power of minus 2 into 36 into 36. From that equation we can get that whenever 36 into 36 is 1296. So 5 into 10 to the power of minus 2 into 1296. By the calculation we can get that 64.8 be the, when the equation for the tension, that is Newton. 64.8 newtons be the tension value. Will the tension, we can get the tension value whenever the tension in the string will develop 64.8 newton tension will develop in the string. This is the value for first. A stretched wire of length 0.6 meter is observed to vibrate with a frequency of 30 Hz in the fundamental mode. So that's why we are taking that nu1 is equal to V by 2L. From that nu1 is equal to V by 2L, we got the value for 36 meter per second. By applying the values, 36 meter per second with the velocity of propagation of a transverse wave in the string. Then after that, to find the tension, the velocity of equation whenever the wave in a tension of a string then V is equal to root T by mu is the equation. T means tension, M be the linear mass density. In the problem we have the value for linear mass 0.05, that is linear mass M. Then from that, if we modify the formula, then we can get tension T is equal to M into V square, that is T is equal to M value is the 5 into 10 to the power of minus 2, then into 36 into 36 means V square means V means 36, so that's why 36 into 36. By multiplying this, then we can get that 64.8 Newton value, 64.8 Newton value. With 36 into 36 will be 1296, 1296 into 5 is 36480 into 10 to the power of minus 2, then we can get 64.8 Newtons tension develops in the string. This is about this problem. Next we are going to discuss about next problem is this is the most important problem, several times got in a public examination for Board of Intermediate Education Telangana and Andhra Pradesh. So a closed organ pipe 70 centimeter long is sounded if the velocity of sound is 331 meter per second. What is the fundamental frequency of vibration of the air column? Already mentioned that closed organ pipe. First of all, we should know, take the values. What is the given data? Given that first L is equal to 70 centimeters, means already given that 70 centimeters means already we know that the values should convert into the SI unit, because it is given in centimeters, so that's why 0.7 meters. And if the velocity of sound is 331 meter per second, means velocity V is equal to 331 meter per second. Then he asked for what is the fundamental frequency of vibration of air column for closed pipe. For a closed pipe, the fundamental frequency nu 1 is equal to V by 4L. For closed pipe, closed organ pipe, V by 4L is the equation. Then from that 331 by 4 into 0.7. 331 by 4 into 0.7. Then 331 into 0. Means 331 by, here we can get the value, that is 4 into 7 by 10 for the calculation. By that calculation, so in the calculation we can get 331 by 4 into 7 by 10, that is equal to 3310 by 28, that is which is approximately equal to 118.2 Hz. That means similarly we can write that 118 Hz. 118 Hz means when a closed organ pipe 70 centimeter long is sounded, if the velocity of sound is 331 meter per second, what is the fundamental frequency of vibration of the air column? He asked for the fundamental frequency of air column in a closed organ pipe. So first the length we have taken, that L is equal to 70 centimeter, that is equal to 0.7 meter. Then after that V is equal to 331 meter per second. From that value, for closed pipe we have the equation for fundamental frequency, that is nu 1 is equal to V by 4L, that is V is equal to 331 and 4L means 4 into L length of closed pipe is 0.7 meter. Then from that value we can, by the calculation we can get that 118.2 Hz, that is approximately equal to 118 Hz. This is about the most important problem in the public examination. A vertical tube is made to stand in water so that the water level can be adjusted. Sound waves of frequency 320 Hz are sent into the top of the tube. If standing waves are produced at two successive water levels, of 20 centimeter and 73 centimeters, then what is the speed of sound waves in the air in the tube? Means when a tube is made to stand in water, means here is the water, whenever it is made to stand, then at the scale has to measure the length Then whenever get sounds produced, then 320 Hz, the frequency will be 320 Hz. At the water levels, two successive water levels, means if the standing waves are produced in two successive water levels, so one is the 20 centimeter, another one is 73 centimeters, then what is the speed of sound waves in air in the tube we asked about. First of all, what is the values we can write that. That is the frequency given that nu is equal to 320 Hz. Nu is equal to 320 Hz. The length of air columns produced, standing waves produced is L1 is equal to 20 centimeter and L2 is equal to 73 centimeter. Means he has given the centimeter. After that we will convert it to the SI units. Then we can get that values, that is from the equation to what is the speed. He asked for the speed, means when the air columns and from the resonance we have derived the beat frequency formula, that is V is equal to 2 nu into L2 minus L1. 2 nu into L2 minus L1. From that formula, 2 into nu means 320 into L2 minus L1 means 73 is the L2 and 20 with the L1. From that formula we can write that 2 into 320 640 73 minus 20 50 centimeters is there. So we are converting it to the meters. So 50 into 10 to the power of minus 2 meters. 73 minus 20, 53 into 10 to the power of minus 2 meters. Then by the calculation 33920 into 10 to the power of minus 2 means 339.2 meter per second with the value for the velocity of a sound, speed of sound waves in air in the tube we can calculate. Means 339.2 meter per second means here 640 into 53. 640 into 53 we can calculate the values. 640 into 53, from that value we can get that So from that 33920 33,920 into 10 to the power of minus 2, then 10 to the power of minus 2 taken there, then 339.2 meter per second be the speed of sound waves in the air in the tube. Means when a vertical tube placed in the air water, then we can get the two standing waves at a certain two levels. That levels can get the by the values. This is the velocity, this is the speed of a sound. With the speed of this sound we can get the standing waves at 20 centimeters and 73 centimeters with the frequency of 320 Hz. Thank you.